Suppose a computer chip manufacturer rejects 2% of chips. So the probability it's rejected is 0.02. Okay? Number one mistake with probability is not converting the single digit percentages to the correct decimal. Because they fail pre-sale testing. What is the probability that the fifth chip you test is the first bad one you find? Okay, is that geometric or binomial? This is geometric. 0.02. Okay, that's my probability. The first one I get, or the first bad one is the fifth one. So that means my probability of failure is 0.98 to the fourth, because the first four work, right? And failure is actually working, or not being rejected. And the last one is rejected. Now, let's use this time to talk about how you can use the calculator. I didn't show you how to use the calculator because I didn't want you to use the calculator command last night, but now I need to teach you how to use the calculator command. So, hold on, let me put this up here. So get your calculators out. This is going to save you so much time, especially with the second question. All right, so in the calculator, our geomet and binomial distributions are in the distribution menu. Second distribution, oh wait. So we were finding the geomet PDF and CDF functions. They're in the same menu as the normal CDF and normal PDF. Okay, second distribution, distributions above the vars. I go up when I'm in the menu because your geomet PDF is at the very bottom and your CDF, and your binom PDF and CDF are right here towards the bottom as well. So this is a single value. I want to know what's the probability of one thing. What's the probability that my first defective chip is the fifth one I see? And so that is a PDF, point, single value, okay? And it tells me what I have to put in. These calculators is why we upgraded the calculators, because it gives us information as to how to use the function. P is our probability, 0.02. And the x value I'm interested in is 5. And I hit enter and paste. This is how I'm going to write it on my paper. Geomet PDF 0.02, 5. And then there is my answer. So, in the calculator, we have geomet PDF 0.02, 5, and that was 0.01845. Okay, so that was A. This is how to do it by hand, and then there's your calculator. But that's what the calculator does for you. Okay. Now the second question is, what's the probability you find a bad one within the first 10 you examine? That word first means I'm finding one bad one. It's either the first one I grab, or I get a good one, and the second one I grab is the first bad one, or the third one I grab is the first bad one. So this is cumulative. So the first bad one is among the 10. So that's adding the probability that it's first, plus the probability it's second, plus the probability it's the third one, all the way up to the probability that it's the 10th. That's a lot, right? If you did this by hand last night, which you should have, it would be 0.02 plus 0.98 times 0.02 plus 0.98 squared times 0.02 plus ... plus 0.98 to the 9th times 0.02, right? And here's where we really want the calculator function, right? Because that was a lot to plug in, all the way up from 1 to 10. So the geomet function, CDF, will add all those up. There is no greater than or at least for the geometric. because geometric goes on forever, right? It could be, the first one could be the 100th one. There's no ending point because there's no fixed number of trials. So this would be in our calculator, geomet, CDF. CDF means cumulative, adding it all up. Think about your cumulative GPA. It adds up your GPA every semester of your high school career, and that's what C stands for, cumulative. And I still plug in 0.02. And what's the X I'm interested in? 10 this time. So we're going to find it in our calculator again. Second distribution. Go up. Geomet CDF is at the very bottom. My probability is 0.02. My X values are 10. And it will add that all up. I get 0.1829. Okay, so that's your geomet calculator command, geometric. Okay, really handy if you're adding up a bunch of numbers. Like if you're adding up to 3, not a big deal, but adding up to 10 is a lot to do by hand, and the calculator does that for you. And you're allowed to use the calculator as long as you define your function like this at the beginning. If I define this, that I'm using the geometric function with a parameter of 0.02, then I can use the calculator commands. Okay, I'm going to get another slide because of all the video things for 15. Number 15 says only 4% of people have type AB blood. D, right? So on average, how many donors must be checked to find someone with type AB blood? Do we get that one, A? On average, how many do we expect? That's asking for what? Mean, right? So 1 over P. So A is 1 over P, 1 over 0.04, which is 25, right? Because 0.04 is 4 over 100, and then reverse 100 over divided by 4 is 25. So D says, what's the probability we won't find type AB donor before the 10th person? So that means the first 9 people are not AB, right? We don't know what happened on the 10th trial. It doesn't say we found them on the 10th trial. It says we didn't find anybody before the 10th. So we're adding so that's the probability the 9 are not AB blood. So 0.96 to the 9th power. And the reason I'm not multiplying by the 0.04 is because it didn't actually tell us what's happening on the 10th trial. It just said I didn't find anybody before that 10th trial, and then here's your 10th person. We don't know what's going on with them. This is 0.6925. Okay. And 17. Assume that 13% of people are left-handed. Probability of being left-handed is 0.13. If we select 5 people at random, find the probability of each outcome described below. What's the probability the first lefty is the 5th person? Is that geometric or binomial? The first, that word first should clue you into that is geometric. Okay, it told me we're picking 5, but it's still talking about it being ordered. That the first person that is lefty is the 5th person we contact. That's geometric. So 0.87 to the 4th, right? 4 failures, and the 5th one is a success. Your calculator is geomet PDF because I just want a single value. I don't want to know if it's among the first 5. So 0.02, 5. No, sorry, wrong probability. That was the last problem. 0.04, 5. Yeah, that was the previous one. That was the last one, and that was the probability of the one before. How about 0.13? Yeah? Maybe I can get the right problem here. Yeah?
How does 17 differ from 15?
15D?
Yeah.
Because 15D is just asking, what's the probability we do not find someone with type A blood before the 10th? It's not telling you that you found the first AB person on the 10th.
Oh.
It's saying, I just didn't get an AB person before the 10th person. So I don't know what happened on the 10th.
But 17 is saying you found the left.
Yes, my first lefty was the 5th person,
Okay.
right? So it tells us that.
So is 15D binomial and 17?
15D is neither binomial or geometric, just straight up probability. Yeah, because I don't know what happened on that last trial. It's just not AB, not AB, not AB, not AB, not AB 9 times.
So if there's a question where it asks like geometric or binomial and it's neither, you just put that.
Right. It doesn't have to be geometric or binomial, right? Most of what we're going to do in this chapter will be, right? But when we get to the test, not everything is geometric or binomial. Some of them is the earlier probability chapters we did. Okay, so that was A. And B, what's the probability that there are some lefties among the 5 people? How would we define some? 1 or more, right? So the probability that x is greater than or equal to 1 is 1 minus the probability that x equals none, right? Or is some defined as 2 or more? I'm not sure. So this is binomial, but the calculation is, there's only one way to get 0 out of 5. So that 5 choose 0 that I would use in the binomial calculation is just 1. So I end up just needing to do the 0.87 to what power? 5th, right? Because I have no lefties, right? None is no lefties. So there's 5. I could do 0.13 also to the 0. But that's just 1, right? And if I do 5 to 0, which technically this is what it is, but this is equal to 1 and this is equal to 1, so it's still 0.87 to the 5th. Okay? So 1 minus 0.87 to the 5th is 0.502 or 16, whatever. See. No, I do not need to write those 2 things down. Letter C, the first lefty is the 2nd or the 3rd person. So we're back to looking at geometric, right? The first lefty. So what's the probability? It's 2nd. This is geometric. This one you can't do with the calculator, or the calculator command. I have to do the first lefty is the 2nd, so 0.87 times 0.13. 2nd person is a lefty, plus, what's the probability of the 3rd person? 0.87 squared times 0.13. Okay. And that is 0.2115. Rounding to the thousandths or 10 thousandths, not a big deal. Whether you choose to do thousandths or 10 thousandths. Don't start rounding to the hundredths and the tenths, okay? Especially with these. It takes off, especially if you need to use that number again in another calculation, it takes off too much accuracy. Yes?
So I can do it on my calculator, so like would that be acceptable on like the AP exam?
As long as you define the model. If you have to define the model as geo 0.02, why do I keep writing 0.02? I'm like stuck on that first problem. You have to define the model and you have to make sure to write down what you plugged into the calculator, kind of. Like I plugged in this, comma 2 plus this, comma, because you could technically do GeoMet PDF 0.02, or sorry, 0.13, comma 2 plus GeoMet PDF 0.13, comma 3. And your geometric CDF doesn't, because you're able to put like a lower and an upper boundary. Yeah, see, ours only does from 0 to the number. Yes. I'm just really wary on the AP exam and probability problems. Okay. There are exactly 3 lefties in the group. Now we're looking at binomial. It's binom 5, comma 0.13. Okay, that defines our model. What's the probability? There's exactly 3. So probability of 3 of 5 is 5 choose 3, 0.13 to the third, 0.87 squared. In the calculator, this is binom PDF, P point single value, and it's 5, comma 0.13, comma 0.87. Oh, no, comma 3. It can do that calculation. Okay. So again, let's look at how to do the calculator. You're in second distribution menu. You're going to go up to binom PDF, and it tells you the number of trials, 5. The probability, 0.13. The x value is 3, and enter. We get 0.0166. And then E. There are at least 3 lefties. So probability that x is greater or equal to 3 is 1 minus the probability that x is less than or equal to what? Ava. Because the probability of a lefty is 0.13, and it was 3 lefties. And the probability of not being a lefty is 0.87, and there would be 2. Right? If there's 5, the exponents have to add to 5. Okay? And the probability of success to the number of successes. Okay? So probability that x is greater than or equal to 3 is 1 minus probability of what? Less than or equal to what? Is it 3? It's 2. Remember that I have to lower this by 1 so that I actually include the 3 in my calculation. So this is the probability, 1 minus probability of 0 of 5 plus probability of 1 of 5 plus the probability of 2 of 5, which in the calculator I can do binom CDF because I wanted to add up several values. Cumulative, add it up, right? And that's 5, comma 0.13, comma 2. So again, second distribution. Go up to binom CDF. Trials are 5. P is 0.13. It looks the same. The information I plug in is the same, whether it's CDF or PDF. So that's 1 minus that answer is 0.179. So this is 1 minus 0.9821, which is 0.0179. And then F says no more than 3 lefties. No more than 3. So that's the probability that X is less than or equal to 3, right? No more than 3 means 0, 1, 2, or 3 in the group of 5, correct? So this is your binom CDF 5.13, comma 3. Now by hand, it's 5 choose 0, 0.13 to the 0, 0.87 to the 5, plus 5 choose 1, 0.13 to the 1 success, which means 0.87 to the 4 failures, plus 5 choose 2, 0.13 to the 2 successes, times 0.87 to the 3 successes. This is what I subtracted off of 1 in part E, right? The probability of 0, 1, 2, 0, 1, and 2. But this is asking us for less than or equal to 3, so this is 5 choose 3, 0.13 to the third, 0.87 squared. Okay, so that's how to do it by hand, which we don't really want to do, right? But it's really important to know what the formula should look like. Okay, and it's okay if it's a long formula to kind of write out, like if you're adding up from 0 to 10, it's okay to write out 0 and 1 and 2 maybe, and then put plus dot, 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 and then plus 9 and 10, and not show all of them in between when you're going to write it out, because it's like, okay, we understand that you get it. You get what the formula looks like, right? So, and that is always helpful to write out the actual formula when it comes to showing your work, okay? Sometimes we're too dependent on the calculator and we don't show enough, and then we don't get full credit for it, okay?